Alright, so this is going to be a video about the differentiation of the natural log function. And to show you how to do this, I just have an example problem right here where the f of x is equal to the natural log of the square root of x squared minus 4 all over x minus 1. The first thing I'm going to do, the first thing that you're going to want to do when you're trying to solve these differentiation of the natural log problems is you're going to want to simplify the problem as much as possible before doing any calculus. So that means we're going to be using the old algebra topics that we've covered from before calculus involving the log properties. So I have these log properties all listed right here, and we're going to try to use these on this just to simplify it algebraically before ever having to find the derivative using calculus. So the first thing I'm going to do is try to figure out which properties I'm going to use. So in this case, because I'm dividing this function right here by this function, I'm going to use this third right here where it's the log base c of a over b. So I'm going to use that to simplify this function as it's written right now. So this is going to be equal to the natural log of the square root of x squared minus 4 minus, because that's what the property says, you're minusing, the natural log of x minus 1. Okay. Now from here we can do a little bit more simplifying, because if you can see right here, this fourth rule right here, the log base c a to the n, well, technically this square root is really just a half power. So I'm going to kind of rewrite it. Alright, so now I'm going to use this this fourth property right here of the logs, and I'm going to take this half and put it in front, so you're left with 1/2 ln of x squared minus 4 minus ln of x minus 1. Okay, from here now it's a lot easier to find the derivative. So we're going to be using this second derivative formula right here, this d over dx of ln x, to find the derivatives of all of these, as well as using chain rule. So first thing I'm going to see right here, this half is a constant multiple, so trying to find the derivative, what I'm going to do is keep that half in front, and then I'm going to multiply by the derivative of this outside function right here, this natural log right here, which we know is just 1 over whatever's inside of that natural log function. So I'm going to be multiplying this by 1 over x squared minus 4. Like so. So that's the derivative of that outside layer. The inside layer, though, you'd have to multiply by that derivative. In this case is 2x. Minus, now again, the derivative of the ln is just going to be 1 over whatever is inside of that function. So it's going to be 1 over x minus 1 times the inner derivative of this, which is 1, so we don't need to really do anything else with that. Okay, next I'm going to simplify everything as much as I can. So I'm going to take out the half and this 2 here, and then I'm just going to multiply this x by this top 1 up here. So then you're left with x over x squared minus 4 minus 1 over x minus 4. So that's basically finding the derivative of a natural log function. I tried to use as much of these log properties as I possibly could, as well as I'm going to need that formula, that second one down here with the derivative of ln x, to figure out this derivative. Okay, it's really important to know that this blue is what the problem started with. This red is all algebra, so there's no calculus going on for these 3 steps right here. And then the green is when the derivative actually comes into play, so we start using calculus with the green. So that's differentiation of natural logs using an example. If you have any questions on anything in this video, let me know.